now we're in an environment where it looks like the humanoid robot will be the ultimate deployment vector for AGI. And then the home is coming. Like the home is like single digit years away from being able to really, I think, put robots in and be able to do like real useful work for humans autonomously. There will come a time here where you go out and about, like doing errands or going outside, and you'll see as many humanoid robots as you see humans.
Let's dive in. We'll start maybe with actually this thread of like the exponential that's happening in robotics. And I'm curious to get your point of view as far as maybe what's driven that, or like where we are sort of in the exponential curve. And obviously figures, but like Paramount, like sort of on the front line of that exponential. So it's been awesome to see all the progress from you all.
Yeah. So I have like kind of two companies that do like kind of electrical mechanical hardware work, both at Archer, just with like electric VTOL aircraft, and Figure. We build like electric humanoids. I think there's like two things that are really, I think, different now than it was like 5 or 10 years ago. I think the first is we've been able to build, in the robotic space, or even maybe specifically to humanoids, we've been able to like really capable hardware. Like the body in this case is for us gotten like extremely reliable. If you come to our facility and like walk around, there's robots like everywhere. I think there's one like one walking behind me in a minute here, and the robots are just like super like the reliability of the hardware has gotten really good. Both in like the commercial setting when we have robots deployed into a customer, and even our facility. So if you were here walking around, you'd see like a lot of robots, and I don't think you would see a single like hardware failure throughout the whole day. We rarely see like events like this. We do have them. It's just like I think it's just become like more and more rare. So I think even if you have like the best AI in the world, you need like you can't get this done on like mediocre hardware. It's got to be really, really capable hardware. So that's the first thing. I think we've been able to build like electromechanical systems on the hardware side that are really going to get reliable. Like reliable of like you have a very complex mechanical system, complexity is very high. So like up there with like rockets and turbofans and other type of sophisticated hardware. But we've been able to build like extremely reliable turbofans and turbojet systems like here in the world. And I think the same for humanoids. Like in the next I would say that even in the coming years, the humanoid reliability is going to get really capable and really good. So that's the first thing I think has been really helpful. Is like we now have like really good hardware. And 10 years ago, you didn't have that. I mean, like the best robot in the world 10 years ago is probably like Atlas of Boston Dynamics, and that was a hydraulic system. So it only ran for 20 minutes or so. It leaked oils everywhere. Had probably a few thousand psi. Every like valve there, hydraulic valve was about 2,000-3,000 psi. It's like extremely dangerous to be around an extra human to the extent that leaked. But now we have like electric systems that are like I would say safe and like reliable. Kind of like heading down that trend, I guess. And then the second thing I think is we have like robotics is really like a neural net problem in the limit, and we really haven't seen neural nets do well in robots, until recently, almost like the last several years. So we have like we now have neural nets running on board robot that are commanding basically hand positions, head, torso, like basically the whole basically action space of the robot. And it's working really well. Like you're watching, you can watch some updates from us, and you see we put an update out like a week ago or so of a robot just doing 60 minutes of like continuous logistics work. That was a single like S1 Helix neural net that we're running on board the robot, and it's just like it looks like what a human would do in some way, like almost like imitating like very similar characteristics of what a human would have, and we're approaching like human speed and performance of that robot. So that's also something I would say 5 or 10 years ago you just didn't have. So in the case of robots, we have like neural nets working, and I think hardware is getting like more and more capable in general, which is like kind of the two big inputs you really need to make this work.
Yeah, I'm curious about this. I don't know all the historical perspective on Figure, but was the intent always to like jump straight to humanoids, or like was there? And I think about this through the context of I just got a Matic home vacuum cleaner robot, and it's like materially better than any of the other robotic vacuums that I've tried in the past, and like it feels like very close to the sort of future of what you might imagine home robots looks like. But it's like obviously vastly different than a humanoid robot. It's super limited in what it can do, et cetera. So I'm curious, like sort of your headspace as far as like the path to make humanoids work. And obviously you all have taken the approach of like go straight to humanoids.
Yeah, I went straight to humanoids day zero. I wrote like a master plan, like a basically like a like a vision doc. That's on the website now. The first day I incorporated with Delaware, I wrote that and put it out. So I wrote it the first day I started the company, and like for me, like it's like the ultimate meta problem is like trying to solve humanoid robots. So like you have to just go right at it. Like there's some other options of like putting wheels and other type of end effectors like claws and other things on the robot, and it's basically a local maximum. Like it'll put you. It'll basically be like um, it'll be a significant issue trying to get to where you really need to go if you're not designing straight for like the right system from day one. It's basically going to act like a huge crutch for the business. So I thought like my thesis like 3 years ago was that it was possible to go do this, and so we basically like started just building and designing humanoids from day one at the company. Yeah.
One really quick follow up on this, and then sorry, Nolan. I'm just like part of the Tesla master plan was around like they needed to do a bunch of stuff to actually like fund making that happen. And obviously the fundraising climate right now in 2025 very positive towards AI, very positive towards robotics. But do you have a sense of like um, over the last few years, like obviously that it's been like exponentially more interest, like lots more money flowing to this problem. But like, what were some of the early like points of conviction, like as you were actually putting this together, that like this was possible to actually go and build in that direction relative to like, again, going in, incrementally making your way there, doing something smaller, and then eventually getting to a humanoid?
Yeah. Okay. I have like somewhat of an interesting story. Um, Previously before founding Figure, I founded Archer Aviation in 2018, and prior to that, I had an exit, sold a company for a little over $100 million in the software space. So I had a little bit of money. Started going and building like Archer, like with this conviction, like electric aircraft is both possible and like needed right now, and like a solvable problem. And like the funding environment was just like non-existent for deep tech. Like there was just like there was early investors were not funding like Tesla and Rivian and SpaceX, like those type of groups. Same for Archer. I put in like basically like I basically went all in on like my entire like basically like liquid net worth into Archer, but it wasn't. But I still needed like a lot of capital just to make it pull it off. It wasn't like I didn't put enough. I didn't have enough like net worth to make it significant enough. And I remember how just difficult the climate it was for that at that point. And man, had things like it's what has that been now? Like 7 years. Like man, the whole like climate towards like deep tech has really flipped. Last like there's like fully dedicated funds for this. Like people realize now that like probably some of these deep tech companies might be the biggest businesses in the world or starting to become the biggest business in the world. So yeah, so I would say like when I started Figure, I basically also had a kind of a step up in net worth and was able to fund the business materially kind of from the get go. So like right out of the gate, self funded the company. I think we hit like $1 million a month in burn like month 5. And we were just like hell bent on like let's just go build a humanoid. Let's get out there like let's make as much progress. We were walking a humanoid robot that we basically majority designed from scratch within like under 12 months from when we incorporated the company. So I would say it happened. I would say it happened really fast, and now we're in an environment where it looks like the humanoid robot will be the ultimate deployment vector for AGI. Like if you want things done in the physical world, it's like you're gonna have a hard time putting it on a vacuum cleaner or anything else. Like you really want like the AI on board a very high dimensional robot to be able to do work. So we're seeing kind of this emergence of like robotics and AI, which is like I would say. Like it's there's certainly a lot of capital I would say coming into the market in this area because of these trends. And I think beyond all that though, like the robots are working. Like we are seeing the robots starting to do like really useful like work. We can run the robot for in a lot of cases we're running the robots almost all day, and they're performing like useful work. So like you're starting to see signs that like this is actually going to happen now, and we're in the right decade, which is helpful as well.
But I think touching on the kind of transition from software to hardware, I'm always kind of curious to hear, as you made that transition, what challenges kind of take place in hardware that you weren't seeing in software? How do you address them? But also, from an adoption perspective, my intuition is that it's a lot harder to get folks to adopt hardware than it is software, especially with so much software coming out. People can go online, try it out if they like it, maybe become a user. If not, go on to the next thing. Like, how do you envision, and it's kind of a two-part question. So again, first and foremost, challenges in general, and then kind of the challenges around adoption as well.
Yeah, I mean, listen, there's a lot to talk about here. I think a few things, maybe I'll just like a few observations for me is there's on the hardware like side for an entrepreneur, it looks a lot like software like in the limit with 10x 100x longer timescales. So like like a lot of upfront, like some upfront planning, and then saying like, okay, we want to go test this, we want to go do it. Like you go design it, you go build it, you then buy this, like buy things in the supply chain, you bring it in, you early test it, you manufacture it, put it all together, and you see if it works. And like in some cases that took a year that you could do in like maybe days or weeks in software. But there's a lot of this, like I would say, a lot of similarities on. We have this underlying like scientific method hypothesis that we want to go test. It's backed by some like real early, like say customer feedback or some type of other like input, and we're going off and building something. We're going to try to see if it ultimately works, and then continue to iterate from there. The problems now is like you have like very long timelines. You have like very expensive things. You have to actually buy hardware now instead of just like just writing software, and then hardware is just like tough to get out the door. It's like hard to make things actually work once you do it, because you have to make a lot more of that stuff. Or digitally, you can just infinitely scale software in SaaS or whatever to go scale it. So it's just like it's like software it's like a death gauntlet for software entrepreneurs. It's like software entrepreneurship on steroids. It's just like really quite difficult. So, but but I think it's like really rewarding. And I think the one thing I had in my software days is I never felt like really rewarded. Like in software, I couldn't like feel it and touch it. And when we show the product, you have to like log into like some browser and go show it. Just like it's something that like there's something really special about like physically building things in the world. And we spend so much time in a physical world. Like there's so in some way it doesn't get a lot of attention versus software like last 10 or 20 years. So I grew up around a lot of hardware, grew up on a farm, grew up building things. And I just really like after kind of my software days, I was like, I really wanted to get into hardware, like basically full steam, and that kind of led me into Archer and now Figure and Cover and the rest of my companies. And it's been great. Adoption is harder. Everything's just harder. So I would say like software, but like just like turn the knob on like the challenges and difficulty to 11, and then you're here. But the one thing I will say though is that like I'm always like pretty anxious internally about making sure I'm designing for the right thing and heading in the right direction. And in some ways, like software, you really quite don't know, because you're building something, you're getting it out, you're getting early like feedback and testing for users. And you're not unclear if this is going to work. In hardware, if we have this conviction, like okay, we should be flying aircraft instead of driving, like that's for sure going to work, and we can save people time. Or like say building tunnels underground. If you can like build that and make it cheap, that'll for sure work if you can engineer the right product. And the engineering is like relatively straightforward in terms of like making sure that like this is possible stuff to go do. It's like good first order engineering. We have to it needs to be done on a clean sheet, but it's physics and there's rules around this. So in some way for me, it's been like the least stressful years of my career as an entrepreneur, like building hardware, because we have a rule book with physics that we can basically, basically axiomatically attribute back to. And I actually really enjoy it. Like I just, my life as a hardware entrepreneur has been both challenging and enjoyable. And, I like both those areas.
Quick follow up on that too, kind of around the adoption piece. As a team, how do you guys evaluate, who potentially would be the best fit, whether it's an industry? I know obviously you guys are heavy in manufacturing, heavy in logistics right now. Like, how are you guys kind of envisioning as you continue to roll out? Like, is it just kind of waiting to hear from folks like, hey, we think we can incorporate some kind of humanoid robot here? Do you guys have like a list of, 10 industries, 10 personas that you kind of want to go and kind of introduce this to? Just kind of curious to hear how you envision all that.
Yeah, at Figure, we have like two like focuses. We have a focus on shipping robots in the home, just like a very unstructured, high variability environment. So home's like really hard. And then we have a focus on the workforce, like getting robots out to do logistics, manufacturing, healthcare, construction. It's kind of funny because the home is so much harder than the workforce. You would think that if you crack the home, it's like 1,000 times bigger market than the workforce because of the difficulty. Like the engineering difficulty is just so enormous. But it's actually like it's flipped. Like the workforce is half a GDP. It's much lower variability. Like I say this because like the engineering challenge is proportional to variability. So like if at least like lower variability is going to be easier to like integrate autonomous systems into, and you have that like, in most cases in the workforce versus the home. Like if you have to overall generalize to this, so the home is like, and then beyond that in the home, you can probably charge like an order of magnitude more in costs in the workforce in the home. Like the home, you got to build a robot and charge like hundreds of dollars a month too, right? Like in the workforce, like you have enormous ability to make a lot of money, and it's half a GDP. So we kind of focused on those like, basically two tracks. And then, the reality is we're trying to build a general purpose robot. So we want to be able to sign up clients and be able to do theoretically most things a human can inside their facility. So as long as the robot has the range of motion and the payloads and speeds to do it, like we should be able to do all that work. When we signed our like last logistics company, it's funny enough, it wasn't like we looked at that and said like, oh, we like the robot would be great at packages. Let's go after packages and go do it. We said we want to go after a place we can really scale into. We think logistics would be in this industry. We signed up the client. We had no clue what we were going to go do. We walked in at a bunch of facility tours. We found out like small package logistics is like a big part of the operations. They're having a really hard time hiring, hard time on labor, things like that. And we looked at that problem and said, oh my God, like every package is different. They're like poly bags. So like they're moving when you're grabbing them. The pile up is different every single time. This is like, just like impossible to code your way out of this problem. Like this has got to be learned. And so we started like down the learn path. Like this has got to be like almost like I got to go all in on learning for this. We went all in on learning, and right away we were like seeing it working, which was like, I think like really helpful. And now you're seeing some stuff we're putting out. And it's like it's hard to say. It's literally getting better every day now. So put the video out. We're doing like a package every 4 seconds. I saw it Friday. We're doing a package every 3.5 seconds. And we didn't actually clock it yesterday when I was like there sitting at it, but I swear that thing was like so much faster, and it was handling different types of variety of packages much better. It was doing really smart things like moving a package out of the way so it can push another package down the line, and then dealing with like the barcode and flipping the package after that, like almost like really thoughtful, like a chain of thought reasoning the robot was going through to do. So yeah, I think like, at a high level, we're trying to go down those industries. We're trying to like general purpose behaviors out of the robot from a learning perspective. And then we want the hardware to be able to do most things a human can. And we need like, we got to be able to do everything. So like, we probably want to start, our view is like, we're going to like bootstrap this within a jumpstart this in the workforce right now. And then the home is coming. Like the home is like single digit years away from being able to really, I think, put robots in and be able to do like real useful work for humans autonomously. So we're pushing on that track also as hard as possible. It's just like, it's very unstructured and different in every home we go into. So it's a little bit of a harder problem.
Yeah, Brett, to double click on this like delta between software and hardware, I think like at the software layer right now, we're seeing this like massive explosion in productivity where, software developers have AI and they have all these like AI tools and et cetera, and you can really do like, 10x more than you could as an engineer before. Is there a world where you think, or I'm curious, as building a hardware product, I assume like some of those benefits have translated to the work that you all do, but do you have a sense of like how far we are away from any sort of like acceleration as far as like being able to build physical and like engineer physical products and things like that?
Well, I guess a couple things on this. We like from almost like the lever arm here of like the exponential for learning is we need to be able to put robots out in high volumes, and they need to be continuously learning and getting better. We are seeing that here now. We're seeing the robots get better at things they're doing, like the more data, more training they have, things like this. We also are seeing the robots just improving as they're doing things in the real world as well. Those are the things that you really want to put a fleet of physical agents out to the world, and you want them just by interacting with the world, getting smarter about how to accomplish these use cases and tasks and behaviors. So I do think that is happening now, and I do think we'll see that in the coming 1 or 2 years of putting robots out to a fleet of robots out to the world, and um, the use cases the robots are doing are actually getting better daily, and the robots are almost using these like model traces as a way to put back into pre-training for the rest of the fleet. So uh, that's a similar thing. That's basically the ultimate like moat here is you want to get a fleet of robots out to market that are both getting cheaper with scaled manufacturing, and they're getting smarter, and they're collectively sharing that with the rest of the fleet. So you're literally having I mean, I don't know if we've ever seen a technology like this besides like, like in some way like AI LLMs is a system that's going out to the world, interacting with that world, and getting smarter and cheaper over time. And that's what like in the next like couple years we're going to start seeing that really happen. And then ultimately it's like then you're ultimately bottlenecked by how like basically production and how to get like enough robots out the door. We have a new facility that we just got spun up on. We call it BAQ here internally. It's our manufacturing facility for Figure 3. We're actively now manufacturing Figure 3 robots, and I've spent like last like year basically working on that project of like how to do things at high rate. We're doing manufacturing for Figure 3 here internally. I do feel convinced we're going to make a lot of robots. The jury's out on like, can we make them at scales greater than phones per year? So like there's like that's a very hard problem to solve. I do think it's possible to solve that, but it's like that's the next challenge beyond like learning. It's like we're like learning bottleneck now, and then you'll be like manufacturing bottleneck at some point.
Quick question off that too. Sorry, Logan. Obviously the humanoid robots now have vision, have speech, can kind of move like a human as well. What do you think is needed as far as like that next iteration? Is it really kind of just letting those robots be out there and learn? Are there features kind of internally from a hardware perspective that you think are still, kind of a little far away as far as getting it to the level or prestige you want? Or again, is it kind of just like, hey, we need to get them out there. They need to learn. And once they do that, we're kind of ready to rock and roll.
Yeah, there's some product like kind of development things that we're doing internally that'll be needed to kind of enable these things. So, for instance, Figure 3 was like our first production robot designed to be manufactured at a high rate. It's like 90% cheaper than Figure 2. Those are some key things that we need to put like a lot of robots out to the world to kind of like kind of like alluding to your question of like what is like kind of the next step. So we need to be able to get a lot of like cheap robots out the door. So we've been working on that pretty like as a core focus, like manufacturability and cost, basically. Another couple other areas that we're like trying to design through is like just overall safety will be extremely important, especially as we enter the home. And the third thing is like I think our design roadmap is pretty highly correlated with moving more like a human on the both manipulation and locomotion side over time. And that's kind of you could kind of like judge those on by like basically like speed and payloads of the robot and range of motion needed. So we're like the trend line is kind of like progressing, like basically do more human-like work physically over time in our roadmap. And then the next step from there is like how do we integrate at some decent scale a large amount of humanoid robots into the world with like no human assistance, be able to do work every day, kind of almost like what we've seen Waymo do the last few years. So it's like they've been able to deploy a fleet of cars out and be able to show that it's like actually working end to end and lower the amount of human intervention rates over time. We need to go through that period of time for us, and we're doing that right now. Like that's kind of like the stage we're in as a business is how do we get a large amount of robots out over the coming years to the world, and then have them be like reasoning about what they're doing. You don't want any like you basically want like extremely low or no human intervention rates, and just doing work all day long. And then from there, the next step is like you just got to like scale it. You got to scale learning, and you got to scale like manufacturing to like really high levels. So yeah, maybe to answer your question, we're kind of in that phase now. Like we're just going to get more things out into the world physically. That'll help with data collection. It will help the robot reliability. It will help us get better at integrating robots into the world, which is also a hard thing to go do.
Brett, I'm curious to get your reaction to this, and this is in line with this. Like, what are the product features from a robot perspective that you think will come in the future? One of the threads that I saw over the last like 2 weeks was just around like human psychology reaction to robots. and like how like if you kind of make them look silly and goofy, like you humans have a certain reaction to that. And like as I sit here, and for folks who are listening and not watching, Brett has like there's a figure robot walking back and forth every once in a while behind Brett. And it like reminds me of this like reality that like you and your team are like, you know, you're sitting in your office all day seeing this happen, and like it's become a normal experience to you. And I'm curious like what your reaction will be, or like what you think the adoption learning curve will be as like humans become sort of used to robots being around all the time. And I'll give one really quick anecdotal example, which is DoorDash uses some, you know, company to have these tiny little robots that like drive around in Chicago and deliver DoorDash deliveries. And every time we drive by one of them, me and my girlfriend are like, "Oh my god, this little robot is so cute. He looks like he's just trying to find his way around and like looks lost and all this stuff." And like it actually is like a pretty interesting experience. And I'm curious if you think I feel like my general sense has been the reaction to humanoids has been like slightly different, where like it just kind of looks like a human. It's like slightly ominous. Like, have you thought at all about like what the like home deployed version will look like relative to like industrial?
Yeah. So yeah, a few thoughts on this. I think first is there will come a time here where you go out and about, like doing errands or going outside, and you'll see as many humanoid robots as you see humans. And I think that's going to be like I don't know, it's literally going to feel like a sci-fi movie. I think it's going to feel like 50 years of the future got pulled forward to today, and it's going to feel crazy. That's going to happen. You come here, you see like a lot of robots here, and it feels it's awesome. Like, we really love it. We have robots walking around all the facility like all day, and some of them are talking to people, asking if they need water or coffee. Some of them are just walking around and just like on patrol basically, and it's just great. Like we like love seeing robots. It helps get the dopamine up, and it's just we have a lot of folks here for interviews and stuff too. It's just great seeing this stuff. My view is that we have like a perfect we spend a lot of time on like the design and aesthetics of the figure robots. So we have a whole industrial design team. Most of them come from like major automotive groups, and we design we think about like the design of the actual robot itself, but also like the like human machine interaction the robots need to go through to ultimately go in homes. So it's like there's like a long thread we can pull on here, but I think one of the things that you mentioned before, like softening the robot up to make it look like it's non-threatening and things like this. I have like a really strong view here that the robot needs to come off as like highly capable, highly intelligent, and sophisticated, because it is. And you'll build the trust with humans of that robot in terms of safety and privacy, by A, doing the right thing, and B, like executing really well from a robot performance, in the actual use cases it's doing, whether it's home or in the workforce. So I think it does a huge disservice when you're putting like these giant like googly eyes on robots and stuff that are like really capable. They're really fast in a lot of cases. They can do most things a human can, here over time. So like putting googly eyes on, it's almost like you're trying to fool other folks to say you're like this precious little thing that is, like just, really funny and cartoonish. I think it's just like really silly from a design perspective. So like there's some robot groups out there that put like eyes and stuff on the robots and like on a screen and things. And it's just like, it's goofy in reality. And like, these are really sophisticated machines, and they should be designed accordingly in my view. In the home, there's like a whole thing with like safety and privacy, and cybersecurity that we're like going through now. And it's like, to be really frank, it's really hard. Like there's like in safety in the home, it's like, we don't want to fall on any human. We don't want to fall on any pets. So basically means we need to, at any time, 360 degrees, they need to detect any moving animal or human. And then, there's also like I call it like semantic safety, is like, we really don't want to be like knocking over the candle and burning the house down. So there's another area of this where everyone needs to be very thoughtful, even if it is physically safe, needs to be very thoughtful about how it moves through, like say a home, to not endanger anybody around it. So, I think it's just a hard one. You kind of asked a little bit like more like, how do we get like, like society to adopt this stuff? I really do hope there's like this mass collection of like sci-fi nerds like myself and the folks we have here that want humans in their home. I literally have a human in my home this week, doing work. And so I think there's going to be a lot of folks that really want a robot, and that the bar needs to be safe enough, and needs to actually do enough useful work, and it needs to be autonomous, like, and it needs to be like, affordable. Like, those are things that need to all happen, and if we can make those happen, I think everybody's going to want a robot to do the laundry, to like take out the dishes, put them away, like make coffee, make food. Like, you're going to want somebody to do all this work. Like, I wake up in the morning sometimes and unload the dishwasher. It's like, I just like never want to do that ever again. Like, I would like, why, So I think when we're able to show that real embodied intelligence can do things like that for humans and do it relatively affordably, we can run those things like all day, all night. I mean, at night, it can be just like tiptoeing around really slow, putting away all the dishes, or like doing other things. Like, so I think that's going to be a really great, both for the home and the workforce. We need them in both. And I think what you're seeing is, I view that you have like a single robot traversing all of that. Just like you have humans working at home, but you also have humans working in the workforce. You have like we've built both the workforce and home for like kind of average non-expert human. And that's what you're going to see. I think you're going to see one, like almost like a cell phone. You're going to see one platform for a humanoid, and it's going to be software limited for most things it can do for the next 10 years.
Curious too, like, and I'm sure this might be a silly question, but how are you keeping kind of the human in the loop? Like, how does one, let's say I have a humanoid robot in my apartment, right? Like, obviously I'm talking to like a human, but like, what are the controls? Like, how do you actually go about processing what that humanoid robot's doing, and like knowing and having the security of like, hey, I can go to my phone. Is there like an application where I can go and be like, hey, do X, Y, and Z? I know Mantic, I think, has like the app UI layer of it too, but like, what does that look like currently for folks who are like adopting, and how do you kind of see that moving forward? Because I know, kind of going back to your privacy statement, people are having humanoid robot in your apartment, they're hearing, they're seeing, how do we ensure that that's staying within the closed doors and not to a wider audience?
Yeah. So my view here is like the whole like unboxing experience and the whole like default UI for the robot in the home and the robot anywhere in the world need to be done through speech. You mentioned like a phone or computer, whatever. Like, it's so weird when we're like next to a robot and we're opening our terminal on a computer and like asking a command or hitting a button. It's the weirdest. It's super, like, the latency is terrible. It's low bandwidth. It's just like, you need to like, it just takes too much time. You're going to want to just talk to robots. And in the case that you're not with it, you're just going to text it. Every robot we have has an eSIM card inside of it with a cell phone number. You're going to want to communicate with the robot through natural language. And the robots, like our robots, Helix neural net, is language conditioned. So you're just going to want to use we're conditioning everything on language, through language. And that's going to be like the natural default layer for a humanoid in your home. So if you don't want it doing something, you're just going to tell it and prompt it for this. And then as it relates to like, privacy and cybersecurity and some of the other things, it's a really important topic that we're spending a lot of time on. We actually just built our whole privacy and cybersecurity division here at Figure, probably like 4 months in now. To like, we have a small team from like Snapchat and Google that are here that have worked on some of these problems before, both on the commercial, like the corporate side on cybersecurity, and also on the product side. It's like, we have to do like 30 things really well in these areas. It's not like, okay, one thing, you're like, okay, you just do this thing and you're going to be okay. It's not like that. It's going to be really, really dodgy. I think it's also where like another thing is like, we get a lot of questions about like Chinese robots and stuff. I think that Chinese robots are going to have a really hard time in the US or Europe, like deploying into homes and the commercial workforce. Like, I think it's going to be, as of right now, I think it's a pretty intractable problem for that. So I think you're really going to want to build like real like brand trust with the company that you're interacting with. It's more sophisticated than a computer and phone, so it's even more like privacy and cybersecurity here is even more of importance for this problem. So to answer questions, like it's really nuanced, like to do product security and corporate security really well, and then overall how we think about privacy here. So I think it's also a really hard problem. So I don't want to give the impression that like we're gonna solve it all like this year, but we are working on it really hard. And it's an important thing. You definitely don't want the robot ever to be like you want to basically like have rules for the robot down in like non-volatile memory on the substrate of like what it can and can't do. You don't want anybody to have access to like root access to any of the robot for any condition or any case. So there's a lot of things that we're working on now that'll be important to enable like millions of robots in the world.
Brett, one of the things that I've thought a lot about that it sounds like you're actually on the same page with is just like this realization in the last 2 years that I would not be surprised if we have like AI superintelligence sometime very soon. But like as I like look out my window and like I look at the physical world around me, it's pretty clear that like that's actually not going to like I'm going to go outside, the world's going to look exactly the same way that it does right now, and like building that sort of digital intelligence doesn't directly, at least in the short term, translate towards like a changed physical world around me. Like life as sort of humans currently live the physical world, their life in the physical world will be very similar. Digitally, things will be different because you'll have on-demand intelligence. But it sounds like you're like, the humanoid robotics like is the way in which we sort of see that acceleration of progress in the physical human world. What's your take on like the timeline to actually make that happen, and also just like it feels like that exponential is going to be like very slow to start, but then like really take off in a material way. So I'm curious to get your reaction to all that.
It doesn't feel like the future, does it? Future's like arrived a little bit, but it does not feel like the future. I do think a world where like humanoid robots are out and we're all doing all kinds of things for humans, and we can like take flying cars to places and other things. Like I do think that is the future we all want, and I think that's what drives me to like help work on like the companies and projects I have now. Is I do feel like that stuff is going to be important for exciting future. I want to add one thing too, is like we are approaching like digital superintelligence. It does feel near, and that superintelligence today like lives in a server, lives in a box. And one of the reasons why I'm working on humanoid robots here with Figure is I ultimately think like a scenario where we don't solve the humanoid robot is a scenario for me where we approach in digital superintelligence, and we have we have all these agents out, like digital agents doing work for us, for humans, and they're going to need a lot of stuff done in the physical world, a lot of stuff. And to the extent we don't have the humanoid solved, like they're going to be asking humans or forcing or bossing or paying humans to go do this work. We're going to be like this, this slave to this like digital superintelligence. And the humanoid is the perfect deployment vector for this. It can like do most things all a human can. And it needs this like intelligence semantically to really traverse the physical world in this like messy environment. And it's the perfect form factor, and you can't get it in your at home vacuum cleaner or anything else. Like there's no hardware for this. So my view of how to answer maybe your question is that you're gonna first see the humanoid robots built and deployed in a very small amount of places that are doing work all day. And if you have the luxury of being able to go see those things, you're going to come in and be like, oh my gosh, it feels like it's working now. And I think that's probably how we all feel when we take Waymos now. But like, I assume most of the US is not taking a Waymo. So when I talk to call mom up, she's like, it's like, in Illinois, just like Midwest, in the middle of Illinois. It's just like, and I'm like taking a Waymo, I'm like self-driving's here. And, it's like, it's happening every single day. Like human robots are happening, they're working. And it's just on a limited scale right now. And we'll see this very gradual point where we get more and more out, and we learn things. We need to learn how to integrate and how reliability works and how maintenance works and how human interaction works. We work at scale, how like scaling learning works. Like we need like as a company, we're trying to figure that out by deploying robots and getting more and more out to the world. We run a robot like every day in the commercial setting. We also do run them here. So we're getting like real like experience trying to figure that out. And then I think like at this point we've learned a lot, and now we're trying to get more and more robots out. And then as we get more and more robots out, it'll be harder to manage a bigger fleet and having like little less babysitting going on than we like probably had in the past. And then at some point we'll like really crack it, and we'll be able to put like literally hundreds of millions of robots out to the world. There won't be any much difference between being able to get a few 100,000 robots out and millions of robots out. You have to have the same technologies. You can't have you got to have extremely low to no intervention rates. You got to have like default UI needs to be speech. You need to like roughly generalize on the learning side. You need to have scaled learning from humans, like things like this all need to be like you need to learn that, you need to have figured those out by like some certain scale. So our next big push is to get 100,000 robots out the next 4 years. That's what we're trying to go do. That's what BotQ, our manufacturing facility that we open, can do. And we've started now making figure threes. They're actually running. They're actually working autonomously, and we want to scale, to those areas here now the next next 4 years. And if we can hit those numbers, we think we're on a trajectory to put millions out to the world. So, yeah, unlike software, we just can't like digitally duplicate this infinitely. But I think the biggest hurdle here is walking into somewhere and seeing it work. Like that's the hardest part of this whole problem. Is getting it over some period of shift to go in and autonomously do work. In the case of like the package work we just showed, it was done through a Helix neural net, and it had like, I think the latest version we just put out had like 60 hours of additional data. Like before we did any, like it was like didn't know how to do logistics in that case at all. We put 60 hours of data into it, and it did all that work we showed you. And that's just like on the grand scheme of things, nothing. So if we're able to basically start collecting hundreds of millions or billions of hours of human-like data, I think we'd be able to scale these to almost like to like a billion unit scale. You can scale them to like every corner of the world. So that's what we're trying to do. And I think it's just like in these stages that we have to go through because it's hardware and it's super hard. And like we have to learn how to integrate these at scale.
Yeah. One quick follow-up on this, which is like, how much do you think that like fast learning process is just like benefited by like the compression of world knowledge? Like, I don't have a sense of like what your models are based off of, but is it like generally as like the ecosystem figures out how to like compress more and more world knowledge into smaller and smaller models, like you all are seeing like the direct benefit of like the models can just like learn faster because of that, because they already have so much baked into them?
Yeah, that it certainly helps. Like, because we can run those models more locally, we run them faster if they're smaller. We basically use like these VLMs for like semantic grounding for the VLA, like the vision language action model, which is Helix. We run that at like almost like a bigger brain at a S2 level that runs at like basically slower speeds, about 7 to 9 hertz, versus like some of the lower level transformer policies that we have. So we're definitely benefiting from there. The problem there is like those models don't really understand how to interact at almost like at a physics level with different objects in the around them. Like being able to grab an object and really truly understand the proprioceptive state of the robot and how it should handle certain types of objects that might be more compliant or more rigid or whatever that would look like is something that the models don't understand at all. They've had none of that training. There's no YouTube for robotics. It doesn't exist. And so we've had to design all of that work ourselves. We have a VLM backbone in the model, which is really helpful for semantic grounding. And in that whole thing we call Helix, we've done here with, I think at this point, we have 20% of the whole staff at Figure on Team Helix. So it's a pretty significant size for just like the AI team. And the only problem we're working on is like robot learning and how to train new behaviors extremely fast.
I'm really curious, and I think you're a great person to get feedback on this, Brett. Obviously we're talking about superintelligence. We're talking about the idea of incorporating or implementing billions of robots into the world itself. What do you like? How do you envision superintelligence? A decade, 2 decades down the road, like what does it look like for humans? What do you hope it kind of accomplishes, or the goal? Is it to kind of give people, more time in their day to spend with family? Is it kind of unlocking a next level of creativity now that you have these robots that can kind of help you execute these tasks? Like, curious to kind of paint your picture as a society, what this looks like when we hit some of those thresholds and benchmarks you're kind of talking about.
Yeah, the trend line certainly looks as if humanoid robots will be able to do more and more things each year that a human does, and over time do most things better than a human. and this is in we'll see this in our lifetime for sure. And I think that I think then that becomes a situation where any type of like work that you do in the world, whether it's at home or in the workforce, is a choice for humans. It's optional. Like you can choose to cook or do your laundry or make coffee or walk your dog or watch your kids or whatever you want to do, or do construction work, whatever. Or you can have a robot do this. And that robot's going to add significantly to GDP. I mean, we measure GDP like per human today, like per capita, and like these are like basically synthetic humans. So, even this year we'll have robots on the line helping to build other robots at BACU. So, like, you'll definitely see in a lifetime, you'll definitely see robots building robots. And so, like, you have robots building robots. They're going out and doing most work better than a human can. It's faster. It's just more reliable. Then, like, what do we do with our time? Like, what's our purpose in some ways? And that becomes like a really difficult conversation, especially for like people like me that's like been working like most of my life and just love it. Like, and I think about we're building robots and agents out there that are smarter and better than all of us, probably in our lifetime. Yeah, it gives rise to a lot of like anxiety, I would say. So I would hope that people spend more of their time doing things they really love. That could be like skiing, time with family. I hope that we're not sitting here 30 years from now and people are working 50 years of their life and a significant chunk of their lifetime in these physical roles.
Quick follow up on that, and Logan, you can finish off the question. Do you think there's going to be like almost like a Tesla model where it's like, I know Elon's pushing for buy a Tesla, when you're not using it, will go kind of be an Uber or a robo taxi of sorts, kind of making income for you? Do you think you'll get to the line where like every person has a humanoid robot that then they can kind of go deploy to do X, Y, and Z task? That robot gets some kind of compensation, goes back to you. Like, again, just kind of curious to paint this picture and hear what your thoughts are.
Yes, just tell your robot if you're like your buddy or wants to go borrow it, you'll just tell your robot to go over and walk across the street and go to the next door neighbor and go help. You will also have a robot making you money. I will even go as far as saying like robots in the limit will be relatively cheap to manufacture and go out and do like basically like constant work that you'll collapse like goods and service prices long term. Like everybody will be able to afford almost anything, whether it's a haircut or goods or produce or any type of service. Like you'll just collapse all of that. If a robot's doing that, it's just the cost of the robot, whatever energy you need. And if it's on real estate, maybe the cost of the real estate, that's it. And you'll just drop all costs substantially by like synthetic humans just doing it all day and night at like, almost like a limited volumes that you would need. So yeah, you're going to have like, you're going to have a personality. You're going to ask it to, increase its humor setting, be more serious at times. And you're going to talk to it, you're going to text it, and it's going to do work for you constantly.
Yeah. Life is going to be wild. Brett, the final question that we'd like to ask everyone, and we'll leave it super open-ended, is just around like something that you hope happens in 2025, and something that you hope doesn't happen. And it is very vague, but to keep the pressure on you, we always get super interesting stuff. So I'm curious where your head's at on both fronts.
As we approach that, I'm working on, like my company's like Archer Figure and Cover. I want my companies like to do well through that period of time. So hopefully we're out there like creating this like really exciting future. Personally, I really hope we take the next level up in terms of technologies needed to advance the human race. Like we need to be working on, underwater cities, space elevators, or Neil structures, like things that really advance humanity by 2050. Those are like a lot of these areas are starting to become more and more possible. Like the technology readiness levels are getting better, and they're we had like the big audacious goals in the the 40s and 50s and 60s. We need that new bar here for humanity, and we need we'll need like the collective human race and superintelligence to help us get there. But these are possible now in our lifetimes. We hopefully want to go see. So I hope that we're taking that next level up. because I care about like the lever arm of technology to basically just enhance like global productivity and happiness. Like I think yeah, hopefully we have a space elevator by 2050. That'd be awesome. I think it could be possible. Um, and more technologies like that, I think would be like just the most exciting future we could possibly live in.
Yeah, I love that, Brett. This was awesome. Thank you for taking the time to chat with us. Excited to see all the continued progress from you all, and I feel like the future is very bright for all of your companies. So thanks for chatting with us.
Yeah, Logan, Nolan, thanks for having me on. Talk to you guys soon.